Okay, folks, I hope everybody's doing well. We're going to dive into another lecture here, module number 11. And in this one, we're going to be again talking about design patterns. So there's a nice summary here of different types of design patterns that you can look at. We've already talked about them before. I'll give a quick review, but these are some things you might be thinking about now that we've entered the project portion of the course, such that thinking about the architecture of how you design your project, certain classes, might save you quite a bit of time in the future. So this is a topic I want to talk about just to throw some common design patterns at you, and you can choose or select the ones that might fit your project. Okay, so last class we talked about user interfaces, some design principles, things to think about when you're developing an application that faces a user. Okay, so our painting application is, very client-based, and it's a drawing application, obviously, so they have to interact with the user interface. So just some general software engineering things you want to think about when designing your projects. Okay, so, and then in the lab, of course, you get to work on the nuclear GUI. It's sort of a C-based library. It's a header-only library, so it's relatively easy to work with. So that's what we worked on in class. Okay, so if you have any questions or comments, we'll take care of that in the live session. We're back to normal this week. So just some logistics though in the course, your previous labs do. So make sure it's pushed to your team's repository, just so it's ready to go. Milestone 2, there was a request to move it back to December 1st. I'm happy to honor that request just because of Thanksgiving break, although I would like teams to try to check in as soon as possible just to make sure that, again, you're meeting with your project manager, helping debug issues sooner rather than later, and working through any issues with your team. Again, just sooner rather than later, so we're not leaving things to the very end. So again, today's goal is just to continue learning some design patterns. And at the end, you're going to work on Lab 10. Lab 10's going back to code smells. We talked about these a little bit a few weeks ago, but this is sort of, there's sort of a dual purpose for why we're doing it. The lab itself isn't arguably very difficult in the sense that the answers can be found, but it is a nice lab to practice splitting up a project, folks working in different branches, and getting everybody involved in your project and thinking about how you'll divide up work amongst your team members. So that's the real exercise of Lab 10, or at least the thinking that's going into it. You will decide as a team, of course, how to complete it. Okay, if there's other open questions, happy to talk about them, but let's go ahead and dive into design patterns. So this is part 2. We've already talked about them earlier in the semester, which feels like a long, long, long time ago. But just a reminder, remember design patterns are sort of common repeatable solutions for solving problems. They can serve as a blueprint. They aren't the end-all be-all, but they're pretty good at providing some solution towards common problems that show up in engineering. And of course, what makes them design patterns, or at least the ones that are discussed, is typically they're a little bit more flexible, maintainable, and extensive, or allow for this in your code base. Again, as your code bases grow larger and larger, even in this course, where you're probably going to be approaching a few thousand lines of code, these things really start to matter, that you have a sort of well-tested idea in your code base. And if you diverge for that, you should diverge for a good reason. That gets documented. But using these patterns will really help make large projects much more manageable. Okay, so I'm just going to dive right into it and talk about some different design patterns. Talk about some creational ones and structural ones. Those are really the ones that make sense for now. So creational design patterns, if you remember, the goal is just to help us create an object that's sort of this thing on the right here, such that you don't always have to think about which object that you're creating. Again, in C++ especially, this can get a little bit difficult when you're using, say, the new keyword, and you can allocate to different type, and because of the polymorphism allowed in C++. So this is just something you have to, or rather would not like to think about so much in your code. Okay. So again, creational design patterns really, help us with this decision here. And there are ways where you can sort of get around this, trying to figure out which object to create at runtime. Of course, here it is hard coded, but you could sort of have these conditional statements and ask a user to type in what object they wanted to create or load from a configuration file or these sort of things. But again, wrapping these in sort of conditional statements, we could do better. So instead, what we want to do in many cases is sort of, again, use object-oriented features of C++ to create a sort of object creator class. It's going to help us create the right object for us and then give us the right behaviors associated with that object. Okay, so first pattern I want to talk about is something called the factory pattern. And what this does is it defers object creation to subclasses. Okay, so it is sort of as it looks, it's a factory where the different components go in the right boxes here. So I want to sort of introduce a running problem with this, just to give it concrete. A lot of the examples I'll use involve coffee, even though I'm not a coffee drinker, but we sort of understand this idea that we can have a coffee machine and it can make us, lattes, or different types of lattes with different ingredients or different styles. Maybe we want different ingredients like caramels or, milk added to our latte, or maybe we have different styles, latte versus an espresso or some other, dark roasted, or lightly roasted sort of base for the coffee. So what you'd really want is to just maybe take from the user an input, maybe a set of ingredients, and then just get the right object back, okay? So this is where the factory pattern comes in, this idea that you can create objects based off of runtime parameters. Okay, so then the programmer really doesn't need to ever specify which concrete object to create, okay? So we're just going to provide this interface to a factory, go through the factory, provide in some parameters, and then based off those parameters, return a new object, okay? So this pattern works as long as all the classes, all of your base classes here, object A, object B, object C, are derived from the factory here. Okay, so you'll have some sort of like factory for creating objects here. And then this is the interface, and then these are all inheriting from factory. That way object A is a factory, object B is a factory, object C is a factory for whatever this type is. Okay, so we're going to make use of inheritance here. So if we're thinking about this in terms of coffee, here's the sort of UML diagram here. So the product, again, the base class is just coffee here, okay? And then you might have some sort of implementation of that base class here, an espresso, and then a factory method here that creates the right object, and it returns the right so-called factory is what I'm calling it here, but the right sort of coffee object, or the right product that you want. And then finally, the concrete creator would create the right concrete product. So here's your actual object. Okay, let's look at it from a sort of example. Here's just another sort of annotated version of this UML diagram here. This is from Head First Design Patterns, also a nice textbook if you want to see some of these UML diagrams. Okay, but let's look at a concrete example here, or one with coffee. So here's our sort of coffee base class, and we could have this sort of return type here. Okay, and what we're going to do in just this sort of class here for this example is just return whatever the type is and just sort of store that information here, okay, in the get type function here. Okay, so here's an example of deriving a class from coffee. So again, we're deriving from, well, here's an espresso, which is derived from coffee. This is our base class, the derived class from coffee. And then we're going to store espresso as the type. This is just to help us keep track of things. And then maybe print out something from our constructor here. Okay. So in the constructor, we're just sort of recording our data type. Okay, and then if I want, I can create another concrete class. Here's a cappuccino, just some different coffee style. Again, I'm going to do the same thing and record the type here. as our data and proceed forward. Okay. But at this point, you've just seen me create two classes that are derived from another class. So it's almost like having an interface. And we don't really have any factory. We're not taking advantage of the factory pattern quite yet. So we just create our objects like we normally would. I could have an espresso and say, new espresso cappuccino and new cappuccino. But again, we can do better, right? We want to start using this factory pattern. So we're going to create a coffee maker factory class here, okay? And then this factory, what we do know about it is its job is to make some type of coffee here, okay? That's this private class here. Again, that's all its job is to do, just return some type of coffee product here. Coffee, again, just rewinding here, is the base class. Okay, in this case, so I'm just going to have a public function here called getCoffee, or this could be called, this is our factory method for creating the coffee, generate coffee, make a new coffee, whatever you'd want to call this. The idea is, just for the purpose of the sample code, every time I call this function getCoffee, it'll ask the user to take some inputs, which is the goal of the factory pattern, take some runtime inputs, something that the user chooses or while the program's running, or is figured out by some parameter while the program's running, and return the right object. So here we're just selecting the type of coffee to make. User could put 1 or 2, you get the choice, and then you return the right object here. So I'm returning a new espresso. An espresso is a type of coffee here, our return object here. Okay. So here we can see a coffee maker, again, factory being created here at line 76 here. We're going to create a cup of coffee, and then it's going to get assigned from our coffee machine to getCoffee. Okay, so we're just calling this sort of factory method that's going to create the actual concrete class here and fill our cup up with the right thing, either an espresso or a cappuccino, one of our two choices here. And if you put something else in, you get a null object, which is sort of the right behavior. We don't have a given our input parameters here of 1, 2, or anything else. We are generating the right object. So either again a espresso, cappuccino, or a null object. Okay, so that's the factory pattern. And as always, maybe I flipped this too soon here. I want you to think about for a moment. You can pause the slides and think about, what are the pros and the cons to this pattern? What are some things that you could potentially think of here? What are good reasons to use it or bad? So if you're watching this, go ahead and take a moment to brainstorm. And if you're back with us, let's look at some of the pros and cons. So the pros, it's extensible to include objects. I can have another, in our example, a choice here or another way to generate, the other type of coffee. All of the object generation is located in one place, which is super nice. You'll never see code, which again, going back to our main motivation, let me run it all the way back here. You'll never see code that sort of looks like this, where you have lots of new this, new this, new this. Instead, you just encapsulate things into a class, right, where we have our getCoffee. Instead, you'll just see this cup equals, do the right thing here, given either some parameters or calling this or some, function. So object generation is located all in one place. It's in that coffee base class. Okay. If I decide or want to enhance or change this program, I can easily just switch between factories. I can write a different function that's, instead of, going through this dialogue here, I can basically just change this member function very easily and, return different objects in my factory. Okay. So again, factories then are just thus decoupling the creation of products from the rest of the code base. This is the goal, again, of creational design patterns, such that we don't have to, think about or make these decisions. They're just sort of encapsulated in this class and they do the right thing. Now, some of the cons are, though, as you can imagine, this can be complicated and it does require some planning. So, for instance, if you're going to debug this, you would want to look and maybe see, does my factory, in fact, is it able to generate espressos, cappuccinos, but what if I have another class that's inherited from coffee? I need to remember and sort of go back and, make sure that this type is possible and that it can be generated from, whatever the inputs are um, to create it, okay? And then there's a little bit of a performance overhead here that it might be faster to just create one concrete class rather than, jumping through a lot of, we have to go through this base class to generate an object. If we know that we exactly need an espresso, why not just generate an espresso? Okay, so if it's performance sensitive, you probably could avoid factories. Again, you can always just instantiate an object whenever you want. So it might be some speed penalties there. Okay. And then I just have a note here that factories themselves can be derived from more generic factories, so you can have sort of abstract factories. So there is another pattern for this called the abstract factory pattern, where you might want to reuse this pattern and just you can very generically have, instead of coffee, a drink class is the base class, and then you have coffee and tea. And then you sort of have the right factory generated for either tea drinks or coffee drinks, and so on. So you can abstract this further, by having different concrete factory 1. This would be for like your coffee, a concrete factory 2 for our tea, and so on. So you can sort of think of it as different products being created from one class here. Okay. So again, you can make this abstraction even further and further, which is kind of cool. But that's the idea of the factory pattern. Okay. Another one that's sort of related is this idea of a builder pattern, creating object one component at a time. This one, the idea is that you separate construction of complex objects such that you can create an object one at a time. So what does that mean? Well, perhaps the analogy is, you can building a meal at a fast food restaurant in a sort of combo bag with different side items is sort of one analogy, or building a car. So I'm gonna cheat a little bit on this one and show you a video, or there's a video for you to click on, which I think explains it nicely. But the builder pattern sort of outlines steps needed to create some complex products. Again, if we're thinking about a combo bag at a restaurant that has many different combinations, that could be hard to have a combo bag that has a drink, a burger, and fries, and a side salad or something. There's many different combinations of those combo bags. Same thing with building a car. Do you want a car that's blue, red, yellow? What's the color? Is it a 4-cylinder engine, 6-cylinder engine, 8-cylinder engine? Does it have 4 wheels? Does it have 8 wheels? All these different types here. So really, you want to just be able to take all that complexity out of the equation and then just build sort of one object at a time by adding components to it. Okay. So what you'll have then is a sort of concrete builder class that has the means to build each of the different objects. You get different products of maybe different types of cars down here to move forward. So I'm gonna have you watch this on your own. Let me just pause it here. It's a nice explanation. It's using C#. It doesn't matter. It's the same idea in C++. But you have some car that you're trying to build here in this example, and there's lots of different individual attributes that you have to set here. Does it have a sunroof? Does it have an alarm? Does it have MP3 player or whatever CD player? The make, the model, and so on. Okay. So the idea is with the car builder, you'll notice that each of these functions, a member function C# here, it's being shown, return a car builder here. So the model returns this model for this object, and so on and so on. What that allows you to do, which is kind of cool, let me fast forward a little bit, is you can just write sort of these functions like, I want a Ford Fiesta, new Ford Fiesta builder, the builder class. And then on top of this object, as you're constructing it, you're just doing dot add alarm, dot, add doors, dot add, navigation, at dot, whatever. So it's a very You just construct the objects sort of one at a time by adding in these functions and setting their parameters. Okay, so this is quite nice here. Okay, so that's the idea with the builder pattern. Similar approach applies in C++. And again, it's taking away the complexity from having to, for example, have a, normally the way we do this is just have a constructor where we set, 10 different parameters and try to work through things that way. That's a little bit less clear what's going on, what types of objects you're building, how much flexibility you have. But again, when you're just creating the object, when you're allocating it, let me go back to the video here. I don't want to show too much because I want you to actually watch it. But just during the creation, this is the creation point here. Right at this point, let me get my painter here. Here, right, was where we are creating something. This again is where all the complexity is, but right at this point. You don't have to call lots of other member functions or anything like that. Okay. Okay, so let's return back to the slideshow here. To another creational pattern. This one's called the prototype pattern. So this pattern's job is to clone complex objects to create new ones. Okay, so let's say you went through, this, creation of this object here. Here's just some object here that we've created. And, you want to make a duplicate of something else because you've already gone through, set up some objects, set it up properly, all the different properties that you want to do. You don't want to have to use something even like the builder pattern that has, dot this, dot make, dot model, dot, MP3 player or whatever. All those different properties. You've set that up and now you just want to essentially clone that already existing object and then work from that one. Okay, so you can sort of set up a template object and then just keep cloning it and then maybe make alterations. It's sort of like cell division. You're getting a complete clone of an object, and then it might diverge later and do something else, but you have this sort of template here. Okay, so let's assume you have something like an abstract animal class here. So this is the little code I wrote here. You have an animal. Animals have lots of different properties. Hair color, their hair length. Do they have a tail, weight, height, how old they are, their sort of intelligence, stubbornness, or maybe aggressiveness. Many other properties of animals, of course. But you have all these different things that you want to set up. Okay. So what I'm introducing here is this clone function here. Okay, this member function. And let's just sort of look at the C++ again. It's been a while since we've done some sort of deep dives in C++, but we've got the virtual keyword here. So that means a derived class needs to implement the clone function. And in this case, it has to because it has the equal 0. So this is a purely virtual function here. Okay, so derived class must implement how an object is cloned. Okay, so any class that inherits from animal has to implement the clone class. Okay, so let's create an animal. I choose a sheep here. And for the sheep, of course, we're deriving from the animal class. And so we have our sheep, and then we have sort of the constructor here, okay, for whatever it means to be a sheep. And we set its properties. Just directly within the sheep constructor, its hair length, stubbornness, aggressiveness, intelligence, and so on. Okay, and then we can return, when we want to make a clone of our sheep, we can return a new sheep, and it's going to be instantiated with this object that's been created. So sheeps always have, by default in their properties, their hair length is 5, maybe longer. It's stubbornness, aggressiveness, and I don't know what the intelligence is, but 7 for the sheep here. So you have all these properties, and that's what we're doing. And maybe we have other functions that we want to implement specific to this sheep type, and that's fine. But this clone function is the important one. Okay. So when a new sheep is created, notice that we're creating a new object here. So we're getting a clone, which is a new object from this, okay? And again, we're taking this object and we're dereferencing it and creating it that way. Okay, so the question to the audience too is, will this work? You know, there's a little bit of funky C++ stuff going on, but we are in fact implementing our purely virtual function here. So we've got this. It's returning the right type, a sheep here. That's what we're saying, promising a new sheep, an actual object here, or pointer to the actual object because we're newing it. Will this work? And the answer is yes, this will work. This will work just fine because all the member variables are primitives. So this is just a little throwback again to think about shallow versus deep copies here. You know, these are all primitive values, char, integers, and so on. So just a reminder on shallow copies here, just to be a little careful here. So if I'm returning a new object here, copy constructor's already been implemented for us, and we're getting a completely new sheep that's a copy or clone of this sheep here. Okay, pros and cons. Oh, oops, I always showed a little bit early, but take a moment to pause the video and think about these. What are the pros and the cons? Okay, so if you've paused the video and gone through the exercise to think of some of the pros and the cons. So the pros, they thought about, you know, it saves developers from typing so much, right? You don't have to, again, if we go back to our main motivation, we're avoiding this. You know, wherever our object is, .set property, .this, etc., etc. You know, if we've already set up an object just the way it should be, you know, and we want 50 of them, why not use one of them as a template? Okay, we're getting rid of all that initialization code. Then it's pretty easy to just see when something's a copy or at least starts off as a clone of another object. The cons are, you know, this could lead you to, you know, bugs in the shallow versus deep copy. Again, generally you should just implement your, you know, copy constructor always, right? The three amigos we talked about: constructor, destructor, copy constructor, and then copy assignment operator as well would need to be implemented. There's actually a fifth amigo called the move constructor. We haven't talked about that, but we don't have to muddle things up. Just know that it's a con that, you know, you have to get your copy constructor right, which I don't know if it falls as a con because you should have to do that in general, but you might have to be a little bit careful. You know, if there are circular references, you know, depending on how you're doing the deep copy, if you have, you know, multiple copy constructors that need to be invoked because you have an object that's nested in many layers of inheritance, that could be potentially a problem. But just some things to think about with the prototype pattern. Okay, so let's move on to some structural patterns, or a structural pattern, one that might be relevant. I think all these could be relevant or deployed, or maybe one of them, that's for you to choose. But this one's called the decorator pattern, okay? And this one converts one interface to another at runtime. So just thinking again back to what structural patterns are, we talked about one, the adapter pattern, which again was about sort of working with different interfaces or allowing us to, and that was the goal. So again, for the decorator pattern, our goal will be to convert one interface to another during runtime, okay? So sort of our running example, again, just to think about, you know, creating a beverage or a coffee or something in this restaurant we're trying to open, I suppose. You know, you wanted to have many different coffees. You know, we're learning, I'm learning what coffee is, I guess. Espressos, lattes, etc. are all different. And, you know, we could have many levels of inheritance and sort of come up with all these different, you know, the house blend with steamed milk, you know, that's a separate class. And then you have the decaf with steamed milk and mocha, and that's a different class. And they all just inherit from this beverage class. You know, it's fine, but you can easily see how this gets out of control, even for just a simple restaurant, right? And this, of course, is a reality. Some restaurant needs to implement this because we need to get these objects into a database somehow and, you know, draw that information from them. So anyway, we've got a little problem here. And if we change this interface for what it means to be a beverage, then we have to change everything that we inherit from. Okay, so we don't necessarily want to do that. And we still also sort of have this problem, we've talked about, well, okay, if I change this interface and add something or a virtual function, I have to implement it many times. So why not just embed everything, into beverage? This idea of milk or soy or mocha, whip, or all the different, properties we could think of that go into a beverage, and then sort of have all of these different functions here. This is a little bit cleaner. Then we just have, some, we have much less inheritance complexity here. The hierarchy wasn't deep here because these are all sort of level 1 here. They're all derived directly from a beverage. So that wasn't a problem, but there were just sort of too many here. And then here, this is still a little bit dangerous here because there's something called the open-closed principle. Okay, so this means that this class here, should be sort of open for extension but closed for modification. Okay, so what does this exactly mean, or what's being violated here? Well, this idea that it's open for extension means, I should be able to sort of extend out beverage. This is fine. I can do it by sort of inheritance, but close for modification. But if I'm adding to all these sort of properties here, milk, soy, mocha, whip, maybe I add caramel or something, it's modifying all the behaviors of everything else. And then I have to add another function, has caramel and all these different properties here, which modify everything else, okay? So, this sort of open-closed principle, again, is, nice principle to keep in mind for your classes, and especially when you're using sort of inheritance here, okay? Because again, if you have to refactor your software, sometimes you get in a little bit of trouble here, where, I'm adding more things to my beverages. Now, is this going to break my unit test because it's not testing everything here, or maybe a function here where, I added caramel here, but do I have to modify the cost function now and get the description and also modify that? And then maybe that changes behaviors of the house blend printout. So I have to, sort of modify this to see if that includes, this new ingredient for each of these different classes. So it just becomes a little bit difficult here, where I haven't really extended. So extending it by inheritance would be fine. But, modifying this starts to cascade, changes in all sorts of places in our code. From the unit tests that we write, from classes that inherited, and so on. So it's generally better, and this is sort of our wisdom here, if we can just extend our classes rather than, continually modifying a base class, okay? So our solution is, again, sort of to go back to using inheritance and have different subclasses to add functionality as we need it, and sort of do this dynamically, okay? So here's our component, then we'll have another concrete component, and then this new decorator class is the new innovation here, okay? So let's think about this with our coffee example, just something to run with here. We have some general beverage at the top that we want to make here. So this is our sort of most abstract class, or our base class where we're going to derive from. And then we have the different types here: the house blend, the dark roast, espresso, decaf, and so on. And they just have a very, basic, the cost of each of these, okay? And then we have all the different ingredients that we want to mix and match. So our milk, our mocha, soy, whip, maybe the house blend is, let's just say all 4 of these. Again, not a coffee drinker, so I can't tell you exactly, but let's say it has milk, mocha, soy, and whip. Okay. So what we're going to do instead is just have this class here that is extended from a beverage, so it inherits from a beverage, so it is a sort of type of beverage. And this can then describe, or rather, let me be clear that this is a component inside this beverage, that you have different condiments that can go on the beverage of milk, mocha, soy, and whip. So you're just extending from here at just sort of one level here. So if I add another new ingredient, I'm not touching the base class here, which would have to, touch all the other classes that all the derived classes from here at every level. Okay, so it's just being extended from one thing here, right? If I add another new ingredient for pumpkin spice or something for fall, like it's added here, that makes it very clean for us to do. Okay, so the left side of the tree here are the different concrete implementations of the beverage. And then the right side of the tree here just shows all the different ways that we can extend or decorate our beverages here. Okay, so I think this one, I'll walk you through an example here. This one could be particularly interesting for folks thinking about their paint programs and adding different, brushes or functionalities. Here's sort of the drawing. Here's the different ways we can draw, and then maybe some ways that we can sort of decorate our brushes. Okay, so something to think about here. Here's the same sort of UML diagram that I just went over with some more annotations if you want to read through. Okay, so let's just start off with a regular interface for our beverage here. Again, this is our abstract class, and we have our destructor here, and then let's just say we have this string for ingredients here. Okay, this is our abstract class. So everything's a type of beverage. I put the I in front of it just so it's clear that it's sort of the interface. Okay, and then we have our concrete components. So in this case, let me just put in espresso here. And it's going to implement the interface from which it's derived here, beverage here. And I'll go ahead and just set the ingredients to espresso with a space, sort of a clean way to do it. So it's a little bit boring, but that's fine. Here's an espresso. But now the beverage interface, a decorator, is also derived from the same parent class here. Okay, and again, since it's derived from the base class here, beverage, it is also a beverage. Okay, so now here in our constructor, here's the sort of decorator for our beverage, iBeverage decorator, again, inheriting from iBeverage here. Notice that the constructor of our decorator takes in a beverage here, okay? And it's just setting, here's its private, so it's got a reference here to some other beverage that exists, okay? Well, what things before were beverages? Well, this guy, an espresso, because it is a beverage here, okay? Any of our concrete components are also derived from this beverage here. I'm just kind of highlighting over and over again this arrow here. So that means we can decorate one of our beverages, which could be an espresso, with different ingredients. Okay. Okay, so let's create a decorator. So let's extend this class out. Let's add caramel, for example. And I'm just going to take the ingredients and do plus equal caramel, and milk, and you do plus equal milk. And this is two concrete decorator classes. So again, they're derived from decorator, and they all are types of beverages here. Okay, and then this is how we could use it. Okay, so we have a main function. We're going to create a beverage. This one's going to be an espresso. I'm just going to say, hey, this is a new espresso. Okay, so I'm instantiating the concrete type here from our interface. And we could actually combine these with some of our factory patterns at this point, right? We said we're going to try to avoid these new here, but what we could do then is just let's just print out our espresso ingredients with whatever. Let's create a beverage with caramel. So here's a new caramel. But again, in the constructor of our decorator, we're taking in a object, something that already exists. Okay, so we're going to take in this espresso here. Okay, and pass it in. So our first decoration is here, and then we'll again take our beverage and decorate it. So we're going to take this time with caramel. So we've got espressos with caramel, and then we want to decorate it with milk. So we'll add the with caramel here from this type. So we're just passing that in as the constructor, sort of passing it on and on. Looks actually kind of familiar to the builder pattern in a way that we're just sort of like building up this drink, this milk and caramel espresso. That's the idea here. Okay, so new is allocating for the espresso. It's a beverage. And then we're decorating our espresso. And then we're repeating that again. Okay. If we look at this, will our milk have all the ingredients here, the with milk here? Well, yeah, if I print this out, since it was taking in other objects in the constructor, we'll have our espresso caramel, and milk for our final object that's been decorated here. Okay, so this works as intended. So this is a nice pattern again because it made really clean. We'll think about the pros and cons, but if I just sort of go back to this slide here, we can easily add, and extend from just sort of two different places. Maybe we'll have a different type of coffee here. The light roast comes in here. That's a different type of beverage. And then immediately when we add the light roast in, it's a type of beverage, only one sort of level of inheritance here. The depth is sort of 1 on our tree. Here's beverage, and then 1 level down, we'd have all of the different types of coffee. And then we can decorate them in many different ways. Okay, and I can add, again, really only 1 level down. I have the condiment decorator here that's sort of standing in here, but then all of the different ingredients here. Okay, and then this is a nice sort of structure you can find here. Let me go to our example. We're actually using it here, where I have my espresso, and then I create from that espresso, espressos with caramel, and sort of decorating it and building up this sort of object here. Okay, so pros and cons. Go ahead and pause and think about it for a moment. And if you're joining back with us, let's think about them. Let's talk about them. So the pros, again, it provides a flexible alternative to just subclassing with many different layers, or having, hundreds and hundreds of different subclasses, or lots of different combinations, or trying to, use lots of not only inheritance, but composition. Okay. The other pro is, we can modify our objects at runtime. This is kind of a big deal here, that I can just sort of add on these different, components, or sort of do this different decoration, and this might bring in, new functionality, new, in our case, ingredients being listed, but, this could be a new, this is a new class here, so there could be new functionalities that are bringing in depending on the type of object. So again, thinking about this in the form of a painting application, we could be decorating different brushes, adding in different properties, sort of changing the behavior as we like. Okay. Now the cons are, with this pattern, we have to be a little bit careful, is that you could end up with many small classes that complicate your design, but at least there are small classes which are good. But if you have something like this, with the decorator, and you're creating a more complex object, you do have many of these levels of creating this beverage, and then sort of decorating with milk, and sort of decorating. This example, I would actually argue, is you should use something like a builder pattern probably, but this one's fine for just illustrating how it works. But this is something to be cautious about on our cons here. Instantiation of many concrete types may become overly complicated, but that's where you need to think about, do I want to give the user lots of flexibility and sort of do things at runtime to create these different, combinations of objects, or if I know there's only going to be a few common ones, just create those and maybe use a builder pattern, and then, have a bunch of prototypes for each of those. Okay, so I don't know, those are just a few thoughts, a few of the sort of trade-offs and things that you'll want to be thinking about. Okay, so that was just another sort of structural pattern here, the adapter and the decorator. There's many more patterns that we haven't talked about, but go ahead and give yourself a break if you need to recharge, and then of course you can unpause whenever you want. And just a little bit of daily wisdom on this. Again, so just understand the design patterns, how and where to apply them. Again, it can be super powerful, but they're just nice to have in your toolbox to understand them. You'll see them in commercial software or open source projects, appearing again and again, or alterations or slight alterations of them. So, again, think about the problem that you're trying to solve first, then, see if there is a pattern that, matches that problem that you're trying to solve. Chances are there are. The Gang of Four book, or the Design Patterns book, its official title, has about 40 patterns in it. So that's certainly not all of them, but there's books with, hundreds of patterns. So chances are, different common problems, we've looked at undo, redo with the command pattern, have been solved and can prove quite useful. Okay. So at this point, go ahead and complete your in-class activity. Don't forget to be completing those. This one's pretty easy. I'm sure you folks will knock it out. And we will see you very, very soon. And hope everybody's well. And, make sure you get started on the projects, and we'll talk very, very soon. All right. Bye-bye.